Right now, a wall of superheated plasma is racing toward Earth at over 4 million miles per hour. It left the sun yesterday morning, and within hours, it will slam into our planet's magnetic field with enough force to potentially knock out GPS, disrupt power grids, and push the northern lights all the way down to Paris. But here's what nobody's talking about. There's one company whose entire business model depends on what happens in the next 12 hours, and its founder just admitted something troubling. At 2:47 a.m. UTC on March 30th, NASA's Solar Dynamics Observatory captured something dramatic. Sunspot region AR4405 had been building pressure for days. Then it snapped. An X1.5 solar flare erupted from the sun's surface, one of the strongest in recent memory. But the flare itself wasn't the threat. What came next was, the explosion launched a coronal mass ejection, a massive cloud of charged particles weighing billions of tons directly at Earth. CMEs happen all the time, most miss us entirely. This one didn't, and it's moving fast, unusually fast. NOAA clocked it at 1,845 kilometers per second, nearly 3 times the average speed. That velocity matters more than you might think. When a CME hits Earth's magnetic field, it compresses the magnetosphere and sends currents rippling through the upper atmosphere. The faster the impact, the more violent the reaction. NOAA is forecasting G3 to G4 conditions, possibly reaching G5. To put that in perspective, G5 is the maximum level. The last time we saw G5, May 2024. Before that, October 2003. And that brings us to Elon Musk. Hours after the flare, Musk posted on X, major geomagnetic solar storm happening right now, biggest in a long time. Starlink satellites are under a lot of pressure, but holding up so far, that phrase, holding up so far, should concern you. Starlink operates over 9,000 satellites in low Earth orbit. They fly at roughly 550 kilometers altitude, right where geomagnetic storms do the most damage. Here's what happens. When a CME heats the upper atmosphere, it expands. That expansion increases drag on satellites. Suddenly, spacecraft that were cruising along smoothly start slowing down. Their orbits decay, and if the storm is strong enough, they fall out of the sky. In February 2022, a relatively minor storm knocked 40 brand new Starlink satellites out of orbit before they even reached their operational altitude. They burned up in the atmosphere within days.
That was a G1 storm. We're looking at G4.
But the satellite problem goes deeper than SpaceX. GPS, the system your phone uses to navigate, relies on satellites that can be disrupted by geomagnetic interference. During the May 2024 storm, farmers in the Midwest reported that their GPS-guided tractors stopped working. Precision agriculture, which depends on centimeter-level accuracy, became impossible. Banking systems, air traffic control, emergency services, all of them lean on satellite timing and positioning. When that gets fuzzy, things break. And then there's the grid. Remember that piece of equipment nobody's talking about? It's called an extra high voltage transformer. These massive machines convert electricity from power plants to the voltage that travels through transmission lines. They're the backbone of modern civilization, and they're shockingly vulnerable to solar storms. When geomagnetically induced currents flow through power lines, they don't stop at your house. They flow into transformers, overheating the metal cores. If the current is strong enough, the transformer melts, not breaks, melts. And here's the thing. These transformers aren't manufactured in America anymore. Most come from overseas, with lead times of 4 to 5 years. In March 1989, a G5 storm hit Quebec. Within 92 seconds, the entire province lost power. 5 million people sat in the dark for 9 hours because a handful of transformers failed. That was one region. A Carrington-level event, the kind that hit Earth in 1859, could take out transformers across the entire eastern seaboard. But there's another side to this story. If you're in the northern United States tonight, or anywhere in Canada, the UK, or northern Europe, go outside, look up, because the same CME that threatens our infrastructure also creates something breathtaking.
Auroras form when charged particles from the sun collide with gases in our atmosphere. During strong storms, those collisions happen much farther south than usual. NOAA is forecasting that tonight's display could reach as far as New York, London, and Berlin. Under ideal conditions, some models suggest visibility could extend to the mid-Atlantic states.
So what happens next? The CME should arrive late today or early tonight. NOAA will be monitoring in real time. Satellite operators are already adjusting orbits and putting systems into safe mode. Power companies have been notified. But the fundamental question remains unanswered. We know a Carrington-level event will happen eventually. We know our grid isn't ready, and we know the solution. Installing blocking devices on transformers would cost roughly $4 billion. The potential damage from a single severe storm, over $2 trillion. The sun doesn't care about our schedules. It doesn't warn us months in advance. We get maybe 2 days, sometimes less. Tonight, as the northern lights dance across skies that rarely see them, remember what's actually happening. Our star is reminding us that we're still very small and very unprepared. If you're lucky enough to see the aurora tonight, what's the first thing you'd photograph? The sky? Or your phone? To prove the GPS still works,